The total number of all possible messages of a long n character from an alphabet containing m symbol is equal to
n is equal m power n.
The determination of the amount of information that can be transmitted by the entire set of messages of length n from an alphabet containing m different symbols is expressed by the Hartley formula.
L is equal
Quantity of information which carries one character from the alphabet, including m equirable symbol, is equal to
L is equal m.
for the unit of measurement of the amount of information, a value equal to
L is equal minus
the formula. In determining the amount of information in Hartley, m is determining the amount of information in Hartley, Malinki n is
number of characters.
in determining the amount of information in Hartley, Bolshoi n is in determining the amount of information in Hartley, P is in determining the amount of Hartley information, the number of symbols in the alphabet is denoted by in determining the amount of Hartley information, the number of characters in a message is denoted by in determining the amount of Hartley information, the total number of messages of a given length in a given alphabet is denoted by in determining the amount of Hartley information, the probability of occurrence of one of the symbol of a given alphabet is denoted by according to Hartley, a function that allows you to determine the amount of information in a message should always be according to Hartley, a function that allows you to determine the amount of information in a message for an alphabet consisting of one character must be equals. According to Hartley, the function that allows you to determine the amount of information for a less likely message compared to the more likely one should be? According to Hartley, a function that allows you to determine the amount of information in message received by several independent sources for the same alphabet must be
Equal to the amount of information contained in the message.
Right here expressing the property of non-negativity of information.
Formula. With the formula. I know.
Right here expressing the property of monotony of information. Right here expressing the property of the additivity of information. Informative. Right here that expresses the lack of new information in a reliable message. The relation I smaller equal 0 expresses the relation P at P1 Malinki P2 I adding big than I2 expresses the relation expresses the relation expresses full reliability of the message. If the logarithm of base 2 is used to measure the amount of information, then such a unit of information is called. If in measuring the amount of information the natural logarithm of the base is used, then such a unit of information is called. If the logarithm of the base 3 is used to measure the amount of information, then such a unit of information is called. If the logarithm of base 10 is used to measure the amount of information, then such a unit of information is called. A bit is a unit of measuring the amount of information which a base of the logarithm equal to. That is the unit of measure the amount of information which with the base of the logarithm equal to. It is a measure of the amount of information which the base of the logarithm equal to. Height is a unit of measuring the amount of information with the base of the logarithm equal to. Yes. This is the question. In the Shannon formula for the entropy of a probability data source, Hx equal E Ix equal minus Pi logarithm 2 Pi and denotes the symbol H. Symbol X. Symbol E. Symbol Pi. The probabilities of the wholes of the random variable X. In the Shannon formula in source, and the interval is denoted by the symbol. Value. Probability of a random. Pi. The property of non-negativity of the entropy of the data source expresses the relation. The boundedness property of the entropy of the data source expresses the relation. The additive property of the entropy of the union of two independent data sources expresses the relation. The property of the entropy equality of two X sources having the same data distribution expresses the relation. The value of the entropy of the data source, which uses the alphabet from one character, is the value of the entropy of the data source, which simulates the tossing of the coin, is the entropy value of the test question, which with 4 answers for random guessing, is the entropy of the race start with 32 participants is Fisher's information. And mathematical According to Ashby, for a unit of information can be accepted